In this lesson, we'll be discussing the SSS Congruence test. Our student learning objectives: define congruence and determine whether or not triangles are congruent. Essential question is, what is SSS congruence? And below you'll see the Common Core standard. So what is SSS? SSS stands for side, side, side. So the SSS congruence test is used when all three sides of a triangle are congruent to the corresponding sides of another triangle. So when this happens, we can say that the two triangles are congruent. This is known as a postulate, which means there's no real way to prove it, but it's something that everybody knows to be true. One exercise you could do is take three matches and make them three different sizes, and no matter which way you arrange them, if they make a triangle, it's going to be the same exact triangle. There's only one way to make a triangle. Therefore, if we know that there's three sides of a triangle are congruent to the other three sides of a triangle, then those triangles have to be congruent. I know that sounds kind of tricky and confusing. That's why it's called a postulate, is because everyone understands it to be true, but there's no logical way of actually proving it. Khan Academy has a great video that explains the SS congruent test very clearly and concise. So take a listen.
What we're going to concern ourselves a lot with is, how do we prove congruence? Because it's cool, because if you can prove congruence of two triangles, then all of a sudden you can make all of these assumptions. And what we're going to find out, and this is going to be we're going to assume it for the sake of kind of an introductory geometry course, that this is an axiom or a postulate or just something that you assume. And let me actually just write this down. So an axiom, very fancy word. Postulate, also a very fancy word. It really just means things that we're going to assume are true. An axiom is sometimes, there's a little bit of distinction sometimes where someone will say an axiom is something that's self-evident, or it's just it seems like a universal truth that is definitely true and we just take it for granted. You can't prove an axiom. A postulate kind of has that same role, but sometimes you can say, well, let's just assume this is true and see if we assume that that's true, what we can derive from it, what we can prove if we assume it's true. But for the sake of an introductory geometry class, and really in most of mathematics today, these two words are used interchangeably. An axiom or a postulate, just very fancy words for things that we take as a given, things that we just will assume. We won't prove them. We will start with these assumptions, and then we're just going to build up from there. And one of the core ones that we'll see in geometry is the axiom or the postulate that if all of the sides are congruent, or if the lengths of all of the sides of the triangle are congruent, then we are dealing with congruent triangles. So it's sometimes called the side-side-side postulate or axiom. We're not going to prove it here. We're just going to take it as a given. So this literally stands for side-side-side, side-side-side. And what it tells us is, if we have two triangles, and so let's say that's another triangle right over there, and we know that corresponding sides are equal. So we know that this side right over here is equal in length to that side. We know that this side right over here is equal in length to that side right over there. And we know that this side over here is equal in length to this side over here. Then we know, and we're just going to take this as an assumption, and we can build up off of this, we know that they are congruent, that these two triangles are congruent to each other. I didn't put any labels there, so it's kind of hard for me to refer to them, but these two are congruent triangles. And what's powerful there is if we know all of the corresponding sides are equal, then we know they're congruent, and then we can make all of the other assumptions, which means that the corresponding angles are also equal. So that we know that that's going to be congruent to that, or have the same measure. That's going to have the same measure as that, and then that is going to have the same measure as that right over there. And to see why that is a reasonable axiom or a reasonable assumption or a reasonable postulate to start off with, let's start with one triangle. So let's say I have this triangle right over here. So it has that side, and then it has that side, and then it has that side right over here. And what I'm going to do is see if I have another triangle that has the exact same side lengths, is there any way for me to construct a triangle with the same side lengths that is different, that can't be translated to this triangle through flipping, shifting, or rotating? So we assume this other triangle is going to have a side that's the same length as that one right over there. So I'll try to draw it like that, roughly the same length. We know it's going to have a side that's that length. So it's going to have a side that's that length. Let me put it on this side just to make it look a little bit more interesting. So we know it's going to have a side like that. So I'm going to draw it roughly the same length, but I'm going to try to do it at a different angle. And we know it's going to have a side, that looks like that. It's going to have a side that looks like that. And so I'll put it right over here. It's about that length right over there. And so clearly this isn't a triangle. In order to make it a triangle, I'll have to connect this point to that point right over there. And really there's only two ways to do it. I can rotate it around that little hinge right over there. If I connect them over here, then I'm going to get a triangle that looks like this. Which is really just a flipped, am I visualizing it right? Yeah, just a flipped version. You could rotate it a little bit back this way, but then you'd have the magenta on this side and the yellow on this side, and then you could flip it. You could flip it vertically, and then it would look exactly like this. Our other option to make these 2 points connect is to rotate them out this way. And then the yellow side is going to be here. And then the magenta side, is going to be right over here. And that's not magenta. The magenta side is going to be just like that. And if we do that, then we actually just have to rotate it. We just have to rotate it around to get that exact triangle. So this isn't a proof, and actually we're just going to start assuming that this is an axiom. But hopefully you see that it's a pretty reasonable starting point. That if all of the corresponding sides of two different triangles are equal, then we know that they are congruent. We're just going to assume it is an axiom that we're going to build off of, that they are congruent, and then we also know that all of the corresponding angles are going to be equivalent.
So that's all I have for you for this lesson. I hope you learned some things. Hope you enjoyed yourself. Go try your homework assignment, and if you have any questions, feel free to contact me on BBIM or by text or email, whatever's easier for you. And be sure to come to live class, and we can go over some examples. Thanks.